This is a circuit diagram most of the electrical engineers are familiar with. Here, the E is the sending end voltage and V is the receiving end voltage. And R and X are resistance and inductive part of the line impedance. RL and XL is the resistance and inductive part of the load impedance. Let us see how to draw the vector diagram. Let us start with vector V as a reference. So first we have to draw V, whatever the magnitude at an angle 0. Then based on the XL and RL value, the high has to be drawn at an angle theta, where theta is the tan inverse of XL by RL. This is called power factor angle. So after drawing the I vector, now we have to arrive at E. How to arrive E? E is voltage vector V plus some drops across R and X of line impedance. So how to draw the drops? The drop across R is in line with the I. So we have to start from the edge of the V vector with in line with parallel to the I. IR drop. The drop across X should be at 90 degrees with respect to I. In other words, the IX voltage with respect to IS voltage, I will be lagging by 90 degrees. So from IR, you have to draw IX at an angle 90 degrees with respect to I. So if we add the vector V plus IR plus IX, you will arrive at E. To join the origin to the end of the IX, you will arrive at vector E. So the vector E will be at an angle delta with respect to V. So this is a basic vector diagram. So with respect to E, the current I is now at an angle phi. So the power factor at the end E is cos phi, whereas the power factor at end V is cos theta. The delta is called power angle. So, having learned this, let us see what happens if we connect one more voltage source at the load end. In such a fashion, its magnitude, phase angle and frequency are exactly same as V. Now, the current through the load impedance is going to be the same I, what was previously flowing. Similarly, the voltage descending end is E is fixed, and the receiving end V remains as V even now. So the drop across the line impedance is going to be remain same as before. So whatever the current, load current, I has to flow through the line impedance to maintain the same drop so that the E can be maintained as before. So the whole current through the load impedance will be coming through the line impedance. So E on the line impedance current, load impedance current, everything is going to be same as before. So the vector diagram, there will not be any change. But the new source, what it will do, it will just be in floating stage. It will be there, but it will not supply any current. In the next video, we will see, instead of voltage source, if we connect a current source, load end, what happens?